Okay, this is a very interesting question. It's about a wave pulse traveling along a string that's fixed at O. So when this wave pulse reaches the fixed end, it's going to reflect and travel leftward. If there is no change of phase at the reflection, then what should have happened would be this wave pulse comes to the fixed end, it's going to reflect, and it's going to travel leftward this way. But for a wave that reflects at a fixed end, there's actually a change of phase. That means the wave, the pulse, is not going to reflect backward this way. On top of the reflection, it's going to undergo a phase change. So the negative pulse here, the tiny little pulse here, after reflection will become a positive pulse. The positive pulse upon reflection actually becomes a negative pulse. So the reflected wave pulse will actually look like this. Alright? So this wave pulse is going to go this way. Let me just show it again. So it's going to come this way to the right, reaches the fixed end, and it's going to reflect with a phase change this way. Okay? Now next we got to figure out how far the wave pulse has traveled at time equals to 1.5 seconds. So the wave pulse is traveling at this speed, 0.5 meter per second. So at this time it will have progressed by 0.5 times 1.5, which is 0.75 meters. So let's just concentrate on the front of the pulse here. So the front of the pulse should have progressed 0.75 meters. So that's a 0.25, that's a 0.5, and that's another 0.25 to make it 0.75, which means the front of the pulse will have reached point P. And remember, I said that it's going to be reflected in this manner. So at this time, the wave would have just reached here, and this is what the string looks like. Alright, I repeat, because the wave pulse has progressed by 0.75 meters, so this point here will have moved 0.75 meters, which will have brought it back here. That's point P. At time equals to 2.0 second, then it will have progressed yet another 0.25 meters, so it will have progressed by 1 meters. So it will have moved yet another 0.25 meters, so the wave pulse will be here. Okay, what we are supposed to figure out is the displacement time graph at position P. So at this point in time is we start the graph from 1.5 second and we end the graph at 2 second. So at 1.5 second, the displacement at point P will be 0, and then what's going to happen is this wave pulse will progress from here to here. So you can see that the displacement of at point P is going to be 0, and then it's going to be some positive displacement as the wave progresses this way, right? The displacement at point P will be positive, and then back to 0, and then becoming negative, and then back to 0, and then 0 from that point onwards. So basically this will be never mind, I'll just draw it this way, and this is where the 2 second is. Alright, so quite a few things being tested here. First is you gotta understand there's going to be a reflection. There's going to be a reflection with a phase change. So reflection with a phase change. And you also have to figure out exactly how far the wave pulse has progressed, and from there you got to figure out how the displacements at point P look like. Very interesting question.